And this liquid, okay, the water and also the gas mix will be recycled. We have the recycle pump, so the liquid here will be recycled and turn around until we can see that the amount of nitrogen oxide, carbon oxides, or sulfur oxides will be reduced. Then only we will start to release the output air that are being produced in this particular area. So once we see that there will be there are reductions, okay, in terms of the level of nitrogen oxides, sulfur oxides, carbon oxides, okay, at this region, then we will release the clean air. Okay, so if I magnify this area, you can start to see that this is actually a pack of biofilter or or porous material containing microorganism. So what will happen here? The absorption and degradation of the, for instance, this one I give example of H2S or hydrogen sulfide in the air will start to absorb here and degrade after the microbe use up the what do you call this particular hydrogen sulfide, okay, for its for instance is for its growth, okay, for the microbes growth, okay. And then, okay, the degrading hydrogen sulfide will degrading the biofilm, okay. And so it will be here. So, and this is actually the packing of this particular area here. And then the hydrogen sulfide that has been degraded, okay, eventually will be trapped in this biomass biofilm, and only clean air will be produced in this particular process. Hydrogen sulfide, okay, when it's being degraded, it will produce oxygen, okay, that will be released to the air, okay. All right. So the common use, okay, include processing wastewater. So we can also use to process wastewater, capture harmful chemicals or silt from surface runoff, and also conduct microbiotic oxidation of the contamination in the air, so by using these biofilters. So it's something like, you know, if you know your cuckoo or your koi, okay, we have the biofilters, okay, or the filters, not bio, I think it's just chemical filters in the system, in the koi, and also in the cuckoo, for instance. So we have these filters to remove all the debris, all the dirts, all the harmful chemicals from the water, and eventually after it passed through all this porous material, eventually you will get clean water. It's something like that, like that. But this one is for gases. Okay, right. Okay, so the bed, okay, of this porous material need to be humidified, okay, in order to keep the microorganism viable. So throughout the process, this biofilter, the one that I mentioned to you just now, this one can need to be always in the form of moist, okay, moisture, okay, in order to get the microbes to get to work and also to perform the bioremediation process. So the needs to have a uniform porous matrix that allow gases pass through while retaining the microbes. So this area must be as uniform as possible. We cannot have stacks of materials, okay, that will will induce problems to the system. Wherever if stacking of microbes happen there, the process of bioremediation of the gases will not happen in optimally. It will happen suboptimally because of the stacking. Okay, because it's a redundant of material. It needs to be uniform and as thin as possible to allow to increase the volume. Okay, in order for it to absorb the gas properly. Okay, how does the biofilter operate? So when applied to air filtration and purification, biofilters use microorganism to remove air pollution. So you can see what is the air pollution meaning here. You can just use these particular links, okay, to read further. So the air, okay, the dirty air, okay, will flow through the packed bed, and the pollutant transfers into thin biofilm. Okay, so as I did mention to you earlier in this particular site, okay, we have a thin biofilm that is being produced here. If you see this one is on the right side is a picture under this electron microscopy. You can see this is actually the surface, okay, morphology of the trickling biofilters that are in this particular what do you call biofilter system. Okay, this is the top one is actually the less magnified, and the bottom one is a further magnified picture, okay, or image of the porous biofilter. You can see that there are so many pores that within this particular porous material, and this will be the area that where the gas will be absorbed, and also water will be trapped, including the microbes. Okay, right. And then we will allow the air to flow through the packed bed. Okay, and the pollutant will then transfer into a thin biofilm on the surface of the packing material. Microorganisms, including bacteria, we can use bacteria, we can also use fungi. Okay, are immobilized in the biofilm, and they eventually will degrade the pollutant, meaning the gas pollutants. Trickling filters and bioscrubbers rely on the biofilm and the bacterial action in their recirculating waters. So we need the trickling of water, okay, and this will need to be in a form of cyclical form. So the process cannot happen in one way. Okay, you need to be keep doing. We need to keep doing it. Okay, all over again, and again, and then until we will detect that the amount of contaminants in the gas reduce, and we will only reduce. Will only release the non-harmful gas to the environment. So an emission control device uses mechanisms to destroy volatile organic compound and has this air pollutants. Okay, this is actually can act as a emission control device as well. Right. So what are the advantages of the biofiltration? The first one is in terms of the design, it is flexible, and then in terms of the volume of gas that can be treated is high. Okay, and the removal of the harmful gases can be up to 90%, and the operation to conduct this particular process is at lower cost. However, the designs are still developing, which means that we can only achieve up to 90%, not 99%, right? For this particular system, and when we have a huge amount of gas to be treated, we need large areas and large bed volumes. Okay, need to be used in order to treat large amount of gases. Okay, and biofilters are technical appliances that use the biofiltration process to remove odorous compounds and other air pollutants like volatile organic compounds from the waste air. The name biofilter may be confusing, conjuring up the images of the normal filters, which simply separate pollutant from the food or gases, as what I mentioned to you about the cuckoo and koi and so on. But it's about the same, but don't be confused because the gas one is slightly different from the fluid. Okay. In a biofilter, the pollutants are consumed by the microorganism, where in the cuckoo or koi, no microbes are being used. Okay, the compound or the material that are packed in the filter in cuckoo and koi is just to trap the dirts and also the hazardous compound, but there are no microorganisms. So when we talk about biofilter, the word bio is there, so it means that we add on microorganism, which is a biological system, in order to biodegrade. That's why the term is biofilter, and we are conducting bioremediation or biodegrading of the gas. Okay, so the word bio means microbes are there. Okay. And then the term biocatalyst or bioreactor would therefore be more suitable. Okay. However, the name biofilter is commonly accepted and used. So if you go to the I think I will be going to Cebu, Sarawak before my meeting. Okay, this one I'm still not sure, but I will be visiting one of the. For this one is for the microalgae project that has been 95% successful. Okay, waiting for the MOU and another presentation that I need to conduct on 9th of July 2025. Okay, so but when I go, this is still tentative. I'm not 100% sure that it will happen or not, but we are planning to go to the carbon dioxide producer, okay, which is a plywood company that will combust some of the flue gases, okay, next to within the facility, and we want to use the carbon dioxide produced by this company to grow the algae at the site that I will developing the microalgae farm. I will show you later. Maybe next week I'll show you the planning and the design, the slides of the planning and design, so forth, and so on and so forth. Okay, to make you understand further about bioremediation, what bioremediation can do. Okay, all right, to make money. Yeah. Okay, cool. So in this particular system, okay, this particular factory, if I can go there, and then I will show you the place where the gases are being